Hi, we need to talk about equivalency of logical statements. So two logical statements are going to be equivalent if their truth tables are going to match. So let's take a look at examples. So the first one, not P and Q, and not P or not Q. So I already pre-filled the tables. So we have P and Q, which will be true and false, false and false, and negation is going to be false, true, true, true. So that's for this one. The second was not P or not Q. Let's start by filling this out. So not P will be false, false, true, true. Not Q is false, true, false, true. Not P or not Q will be false, true, true, true. So here's what we're looking for. You see these here and this here? They are identical in the same exact order. It doesn't matter how it combines with all the true and false, as long as this matches precisely, then these are equivalent. So these statements are equivalent. Next, these two statements, not P will be false, false, true, true. Not P and Q, so that's these two. It's going to be, not P and Q will be false, false, true, false. The other one is not P or not Q. Not P is false, false, true, true. Not Q will be false, true, false, true. Not P or not Q will be false, true, true, true. So we see that they are matched precisely. Our problem is right. Well, so this matches and this matches, but the other ones don't. So these are not equivalent. Okay. Not P implies Q and Q implies not P. So not P, false, false, true, true. Not P implies Q. You have to be careful, you're going backwards. So false, true is going to be true. False, false is going to be true. True, true is going to be true. True, false will be false. Remember, you're dealing with the conditional statements, so the order is important, and be careful. And then Q implies not P, so not P is false, false, true, true. And then Q implies not P, so we go from here to there. Right, so true, false is false. False, false is true. True, true is true. False, true is true. So this looks like they don't match, right? And then they're not equivalent. P implies Q and not P and sorry, not P or Q. P implies Q will be true, false, true, true. For the second table, not P will be false, false, true, true. So not P and Q, we're looking at these two. True or false is true. False or false is false. True and true or true is true. And false and true is true. Match precisely. These are equivalent. Okay, so now we have a verbal statement. So when you do this, you will always want to write them symbolically first. So I have two. If it rains today, let's call this P. Then I don't go outside, let's call this Q. So we're going to write that as P, then Q. If it doesn't rain today and I go outside, so if it doesn't rain today, it will be not P and not Q, right? Remember, you have to negate this statement, don't go outside, to get I go outside. Let's see what happens here. So here we're trying to show that P implies Q. Here we need to have two additional columns. It will be not P, not Q, and not P and not Q. Let's complete that. So we already did it a couple of times here. True, false, true, true. Not P will be false, false, true, true. Not Q will be false, true, false, true. Not P and not Q will be false, 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 true. They don't match, not equivalent. Okay, this one, so P, if and only if Q, it's a biconditional statement. This will be true, false, false, true. And we're trying to compare it with this one, so P implies Q and, sorry, this should be Q implies P, this should be Q implies P, and this should be Q implies P. And then P implies Q is true, implies true, that's true, and then false, and then true, and true. Q implies P, so we're gonna have to go backwards. True, 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 false, true, 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 false, 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 true. Now one and the other. True, 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 false, true, false, true, false, false, true, true, true. Look at the two completed tables, they are equivalent because all those things match. Okay. If you don't like soda, then you eat ice cream. Let's call that one P, it implies Q. If I don't like soda, then you eat ice cream. P implies Q. If you don't like ice cream, that means it's going to be not Q. Then I like soda, which implies not P. So here we're trying to do P implies Q. And here we try to show, I did not make the extra columns here, but not Q implies not P. So we need to do it separately. What I'm going to do is I'm going to put not P here, and I'm going to put not Q here. So if you don't like soda means P, then you eat ice cream Q, so P implies Q. If you don't eat ice cream, it's going to be not Q, and then you like soda, which will be not P. So P implies Q, true, false, true, true. So here we're going to have false, false, true, true, false, true, false, true. Careful, we have to go backwards here because we go from not Q to not P. FF is true, TF is F, FT is true, and true true is true. Exactly the same. These are equivalent. Now I have some special cases that I want to show you. So P and Q implies P. P and Q, true, false, false, false. And P and Q implies P. So true, 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 false, true, true, false, false, true, false, false, true. If you have, if you complete a truth table and all of the, in the final column, everything is true, this is what we call a tautology. It's called a tautology. Let me rewrite that. Which means no matter what, this particular conditional statement is always going to be true. Let's take a look at this next one. P and Q implies not P. So P and Q will be true, false, false, false. Not P will be false, true. I'm sorry, false, false, true, true. Q implies not P, so we go from here to there. TF will be F, FF will be true, TT will be true, FT will be true. And now we have this, our final statement. So we're looking at these two, TF, T and F is going to give us F, F and T is going to give us F, F and T is going to give us F, and F and T is going to give us F. So all of them are false. This is an example of a contradiction. Okay, which means this is a completely false statement. So in example 8, this was example 8a. This is a statement that's always true, so we call it tautology, which means it's always true. And example 8b is an example of a contradiction, which means it's never going to be true. Okay, I hope this helps.